And we are going to transition into the next talk, which will use the most hyped up term ML for CD, and it will show how we can actually have practical benefits from applying machine learning to our continuous delivery pipelines.
Hey, Ravi Lachhman here with Harness, and thanks for joining my session at Scaling Continuous Delivery. In this session today, human no, machine yes, machine learning and CD, we're going to be going over how AI ML can help you in your continuous delivery pipeline. But a little bit about myself. Again, I'm Ravi Lachhman. I'm an evangelist at Harness. And previous firms I worked at were AppDynamics, Mesosphere, Red Hat, and IBM. So I have a background in distributed systems. A little bit of an odd confession. I believe that all log messages look the same, don't they? And also in my career, I actually broke a lot of stuff. So what are we going to be talking about today? We're going to be talking about no two deployments are the same, decision fatigue, then also help computer. This is where AI ML or artificial intelligence machine learning will step in. So let's go ahead and get started. Deployments, they're as unique as you. So let's take a look at who your internal customer might be if you're a DevOps engineer, or if you're like myself, a software engineer. Going project to project, in my background, I was a J2EE or JE engineer, and I must have been on about a dozen development teams throughout my career. I would basically write Java. I would build it into a particular package archive, like a war or a jar, maybe using some Java, using some JMS for the message part of the application, event-driven part of the application, and then I'll be deploying into one of three target application servers, let that be WebSphere, WebLogic, or JBoss. Now, the amount of infrastructure that I had to know was actually very little. Once I built the war and built a particular descriptor to it, the middleware engineering team would take that over. Now, if you fast forward to today, how much skills you have to have. Now, I'm the same person, but this is what my landscape looks like today. So if you take a look at the Java portion of it, not only is there more share in the language, there's actually a lot more pieces of infrastructure that you have to do. And now when you're cobbling this together in terms of a deployment, there's a lot more orchestration that you have to do, right? So any one of these particular paths can be an application. I might be using Maven and Angular and Java and Chef and Mesos, and let's say I'm using statsd and deploying that to AWS, or I might be using Gradle back to Java and JMS, and then using Jenkins to build and packaging in Docker, putting in Kubernetes, using Fluentd, and deploying to GCP. But you see what I mean? Every one of these paths is a culmination of all the changes that you have. And so when taking a look at a deployment, how are these particular skills transferring team to team? I would say every one of my deployments I've ever been on or releases I've been on, they were completely different than the previous team I've been on. And so why are deployments unique? Well, I was kind of hinting at that. Here's actually a workflow for a particular deployment. Having a deployment that's as unique as you is that you're actually a culmination of multiple teams, right? So if you take a look back at this, you might be having multiple teams again that are interacting with you, multiple areas of discipline, multiple change management processes. And so getting items into production can be very difficult. Now, what's even more difficult is that, let's say, it's one thing if the application is brand new and you're releasing version 1.0 and this is the first time you're doing it, versus, well, if the application is currently running, right? So most of us come in the middle of projects. We're really there for the inception, or if we are, we kind of change teams at some point. And then making sure that how do we go about making changes something that's running. The argument's like, oh, you're trying to change tires in your car as you're driving. Well, it can be fairly difficult. Now, there's technical ways to accomplish that, but again, every application is different. And so when we're going about doing a deployment, one thing that actually it can become quite stressful, even I must have been to production hundreds of times in my career, it's this concept called decision fatigue. And so what is decision fatigue? Decision fatigue is basically, just like the definition says, you're actually inundated with so much data that how you make a decision could actually be quite tiring. And so one of these things might be, well, you're just getting inundated with log data. Now, it's kind of difficult that if you have a distributed system, you can be getting logging data from multiple parts of that distributed application, multiple nodes, multiple services, especially with microservices. If you have several services you have to deploy at one time, maybe they might be a little more coupled than you like. You're just getting bombarded with logging data. And so there's ways that you can actually aggregate this data. There's log aggregators out there or log analysis. But again, if you're looking at distributed trace information, you're getting inundated. Is what is happening appropriate? and also looking out for very fine-grained markers, right? So when you're inundated with these particular log messages, how do you know what's right? How do you know what's wrong? And we're going to kind of get into that in a little bit. And just again, coupling with that is the velocity that the logs are coming at you or the data is coming at you. You know, as humans, we can only process so much. And with particular, let's say, larger applications or more distributed applications or meeting your cloud native scale, you can have hundreds, if not thousands, of nodes. And how do you know that it's becoming successful? And you can start having programmatic ways of validating that these particular applications are successful. And this is where we come into help machines. And so when we're actually deploying something, if you kind of take the machines, we'll kind of step in and out of having the machines and not having the machines. But usually, let's say, let's take the machines out of it. If we were, let's say, two engineers, or for those on the call, let's say that you were the lead engineer and I'm just a staff engineer and we're going through a deployment, you might be like, Ravi, let's go ahead and grep or tail up some logs, right? And so what we're actually looking for are markers of success or failure. And so again, this might be based off of, well, we know the application, this is some tribal knowledge, we have some sort of context. Well, when we deployed the application the last time, this is what happened versus, you know, this, when we're deploying it this time, this is what's happening. And we're trying to manually reconcile this. Now, this is the same data that you could actually feed to the quote unquote the machines of deployment, right? So if you're starting to leverage AI ML, this is exactly the same data that you're going through. You're making a decision as an engineer that you can actually have that data baselined, and also you can start finding irregularities. And it's all coming back to the judgment call, right? Are you going to continue the deployment? Are you going to roll back to deployment? And in modern applications, there's more than logs, right? You're having maybe some sort of, let's say in this specific example, you're looking at CloudWatch logs for an AWS deployment. You're looking at maybe for performance regression. You're looking at, you know, your APM provider like AppDynamics or Datadog. And even just parsing through all that data, you might be using like an elk stack to kind of see other markers of the application. And then, but feeding all of this data instead of that brain right there, you can actually kind of feed that into unsupervised machine learning. So unsupervised machine learning doesn't require any human interaction to actually produce a particular result. And so there's a few algorithms. And so here at Harness, we actually have a few algorithms that we do when we go about deciding if a decision to deploy or not to deploy makes sense. And one of these first, kind of the two big algorithms that I'll be talking about today, it's one called a hidden Markov model, and also we'll be talking about entropy in a second. So what is a hidden Markov model? Well, basically, you have to make a prediction when data is incomplete, right? And so these are basically heats and sinks. So in this example on the left, let's say that if you have two particular outcomes, either it's rainy or sunny, depending on if it's rainy, you're more prone to shop versus if it's sunny, you're more prone to go for a walk. Or if it's rainy, you might be more prone to clean versus going for a walk. And funny, I actually gave this talk in Seattle, and they were like, "Well, no, it rains all the time, so it doesn't matter, you know, when we go outside." But this basically, you want to predict when data is incomplete, right? So during your deployment, a lot of times you're in an incomplete state. You have test data, but the particular control data might be incomplete, or vice versa. You know, you have the control data from a previous deployment, and you're trying to make sure that what is being predicted, what is occurring, is actually being expected, right? And so another way of checking that, and this is a big way of making a judgment call for either success or to roll back, is this concept called entropy, right? And so in the mathematical term, basically what entropy is either the frequency or not the frequency of something. So if something has a low entropy, that means that it's more significant than something that has a high entropy. So if we look at that string, 11111, you know, then 0, then 1111 again, what is more significant? Is it more significant that there's a 0, or there's more significant that there's a 1? And the argument would be that there's more significant that there's a presence of a 0 because there's less of them. And this is when you start doing some sort of automated log analysis that, hey, you know what, we see, say logs or info warning, warning, and then a fatal. Well, which one was more significant? The fatal in English is more significant, but if a particular event happens that hasn't happened before, it has a lower entropy, and it actually is a higher marker that something is going wrong. So something that you didn't really expect. So how does this actually look like? So in the Harness product, we actually have a way to visualize this, right? So we actually visualize the particular log data. So we categorize them into three events, of three buckets. So we have the unknown event, the anticipated event, and then a baseline event. So going back to if you're having items that had a low entry fee, that would be an unknown or unexpected event. If you have items that keep showing up over and over and over, that would be the blue or the gray. Funny story, one of my first projects out of school, I was working for IBM, and I remember trying to deploy to WebSphere at ND for the first time outside of my local dev environment for finding my changes going into prod. And I would see hundreds, if not thousands, of just warning messages in the logs. I would look to the lead engineer and I would be like, hey, what's going on? How is the application server even starting? And she would explain to me, oh, yeah, that's expected. I'm like, well, I never see that. Coming out of school, if I had this many warnings, I would get an F in a particular class, right? And this is what we're doing to filter those particular events out. If they keep happening over and over again, even if you're known, it's still okay. And basically what we're trying to do is actually make a decision to either roll back or move forward. And I'll actually take a look at this really closely. Because again, a lot of times when we're deploying particular software, it's making the judgment call, right? What is the tedious portion of your deployment? It's if you're using a canary deployment, for example, that's when you deploy a small subset. And then if it's stable, keep promoting canary until it overtakes the stable version. It's really looking for that regression, right? That's when you kind of move in and move out. Let's take a look at what one actually looks like here in our particular pipeline. And so here I have the harness platform that's up and running. And so here we have several stages. We'll kind of like ignore these particular stages here. But when we actually do come up to the final deploy to production stage, and here we have a mixture of manual and automated approvals, which we can spatter anyway. Looking at the verification step, making this automated judgment call, we're taking in markers. Now this is overkill. We have several here that most of our customers would have multiple APM providers. We can take a look at something, let's say like your app dynamics. Is there a regression in the web transaction? Is there some sort of regression that we're seeing that, hey, performance is lagging versus, let's say, if we take a look at one of our elk analysis here, here's the eye chart again. Are there new events that are popping up that are anomalous? And if it actually reaches a certain threshold, we can actually say, you know what, based on previous executions of this particular deployment, based on how the application performance is running, it actually doesn't make sense for us to move forward to promote this particular canary in this phase. And actually, by convention, we'll actually roll back the canary. But with that, I'm hopefully giving you a very quick talk on how to start using AI ML. Again, going back to those couple algorithms that we have in your particular deployments. Using the machines can certainly help. And hope you enjoy the rest of the conference. Cheers, Ravi.
Thank you so much, Ravi, for showing us how machine learning can simplify our lives. And it's always exciting to see someone else doing our job. So I'm looking forward to seeing more practice like this. But now I have a question. So it looks like you mentioned that a bunch of things are actually somewhat similar to what Captain is trying to do, because you're trying to evaluate the results of the canary, for example, to automate the judgment calls. So I wonder if you are like, what kind of APIs you're using to query that data? Because you mentioned only logs, but I would assume that you probably also can ingest some other types of signals for judgment calls. And if that's the case, like what kind of signals you use?
Yeah, can you see me? My first time using Blue
Yep.
Jeans meetings. Okay, perfect. Yeah. Okay, good. I'm here. The platform itself can ingest data from multiple sources. So like imagine like you and I are going about deploying something, right? Like in a typical enterprise, you might have multiple APM tools or multiple log analysis tools or even some sort of custom metrics that we're using to determine if it's healthy or not. The harness platform can ingest all of that. And also it's doing baselining. So maybe we deployed something a month ago. It monitors before and after the deployment saying, hey, this is a normal response time for, let's say, a transaction. And then if there's any sort of regression, it kind of goes back. Because that's what's very difficult. I would say all of my, before having a tool like this, like one of the hardest things to do, especially when you change teams, is knowing what is normal. Like let's say you and I work together and you and I split a bunch of different teams. all of my confidence goes out the window. I'm like, I don't know what's normal. My local environment or even a dev environment, sure, the feature works great. But again, like until you get into the wild and not have that institutional knowledge, it can be fairly difficult.
So, so are you using some standard APIs for defining these SLIs and SLOs like the Captain, or it's a proprietary thing that it works only for harness and you
Oh,
have to?
I see what you mean. So like Captain, you can actually define like, hey, this is our SLO, this is our SLI. No, Harness is doing that automatically for you. So it's determining what's normal. You could influence it and give it hints, but we're a little bit more hands off than that. So we lean on the provider tools. Like I'm just gonna pick on like Datadog. Like most likely those thresholds are set up in another tool. And so if you start violating it there, we'll just kind of start influencing the judgment call based on an external tool.
I see. And so you mentioned canaries, but does it also work for maybe non-canary releases? Like, for example, when you decided, okay, this looks good, and then you promote it, but then something happens in production after passing all those checks. Like, do you continue monitoring and trying to perform some remediation strategies, or once it passes all these checks, like you no longer watch what's happening with it?
So part of the product that we have is something called continuous verification. So it actually will check after deployment. I couldn't tell you how many times. Actually, I could count how many times. There's this intrinsic question: when is your deployment over? And the very experienced people would say it's over when the next deployment goes in, right? So you're actually on the hook, right? Regression can happen hours. And I mean, it came to bit me several times. I'll be at happy hour after deployment and get PagerDuty alerts, and I would roll my eyes like, oh, come on. I just went to the bar, please. But yeah, like we take into account that there's regression. Weeks later, we can tell you that something's going on, and then it's up to you to decide what to do. Also, Canary is not the only type of deployment we support. You can put that type of verification in pretty much at any stage. Blue green, for example, doing a swap. You can just plug and play that type of verification.
Cool. And so so far you mentioned that you have this continuous verification process, but so let's say something goes wrong. So are you only able to revert the change, or there are different types of remediation strategies that developers can define? Like, for example, maybe turn off a feature toggle or do something custom.
Yeah, so it would be, you could define the failure strategy. So like by convention, I would say bulk share people would try to respect MTTR, so that they would want to roll back if it's possible. But you can define X number of steps, right? You might fire off a ticket to add a JIRA now if you want to roll forward. You can potentially call as part of a custom action, call a feature flag API, right, if you want to. So those steps are definable. By convention, we would automate the rollback. You can blow that rollback step away and say, I want to do something.
Oh, that sounds cool. Yeah, that's perfect. Awesome. Well, geez, we continue to be behind the schedule. So thank you so much again.
Yeah.
I hope to see you at the panel discussion and continue our conversation.
For sure. See everybody.
Again. Yep.
Cheers.